Next question is, which of the following mutations might confer a competitive advantage to an athlete by raising his or her hematocrit? Before going to the option, we have to know some terms like what is hematocrit, how the hematocrit raising is advantageous to the athlete, and what is erythropoietin, and what is this erythropoietin signaling. After knowing this, we can easily confirm the option. So what is hematocrit? It's a blood test that measures how much a person's blood is made up of RBC. It simply means how much a person's blood contain the how much RBCs are contained in a person's blood. It simply measures the RBC count. So what is erythropoietin role in RBC? Erythropoietin role means when a person is in a hypoxia condition, kidney produces the EPO means erythropoietin, and erythropoietin induce the production of RBC. This is the overall view, and we should know what is the signaling of erythropoietin. So erythropoietin is the ligand and which bind to the erythropoietin receptor. Here the blue color thing indicates the erythropoietin receptor. Red color one is in the erythropoietin, and this outcome of this signaling, this erythropoietin binding to the receptor, leads to the production of RBC. How it is happening is, whenever erythropoietin binds to the receptor undergo dimerization. Here we can see that in the first figure, the erythropoietin receptor in a monomer condition. Then upon binding to the receptor, binding to the ligand, that is the erythropoietin, the receptor become dimerized. Here it is also in yellow color, it is noted like a JAK. JAK is a kinase. Before binding to the receptor, JAK is not phosphorylated. After binding to the erythropoietin receptor, in the second figure you can see JAK is phosphorylated. This autophosphorylation occur whenever the binding of ligand occur. Then this phosphorylated JAK can phosphorylate several residues in the cytoplasmic domain of the receptor. You can see many phosphates are here and here. Many phosphates are many phosphorylation is occurred here, and to this phosphorylated residue a transcription factor called STAT is bind. This bound STAT become phosphorylated. You can see a phosphorylation here. This phosphorylated STAT, two STAT undergo dimerization and it will go to nucleus. This STAT is a transcription factor, so it will moves to the nucleus, and ultimately this transcription factor induce the formation of RBC. So this JAK-STAT signaling is very essential for the activation of STAT and its movement into the inside the nucleus, and ultimately the production of more RBC. So this is the signaling. In the fourth figure we can see that SHP1, it's a phosphatase. Actually what is this doing? It removes the phosphates. Whenever the phosphates are removed, STAT cannot bind there. You can see here the STAT is bound to the phosphorylated residues. So whenever SHP1 is active, it removes the phosphate here and here you can see. So whenever the phosphate is removed, STAT cannot bind and STAT cannot active and it cannot move into the nucleus. So this signaling is stopped. This is the simple thing. Okay. Then we can go to the option. So hematocrit measures how much the RBC contained in a blood of a person. Okay, then how here question is, which of the following mutation might confer a competitive advantage to an athlete by raising his or her hematocrit? It means to raise RBC, what are the mutations are needed? So first option is excess production of erythropoietin. Mutation that confer an excess production of erythropoietin, it's true. So first option, that is A, is true. Then decreased production of erythropoietin, it simply we know it's the false one. And erythropoietin, EPOR means erythropoietin receptor, that cannot bind STAT5. When it cannot bind STAT5 means STAT5 cannot, it will not be active and it will not move to the nucleus, and the production of RBC is not under the, sorry, the STAT5 is not active means RBC production is not promoted. D, option D is EPOR receptor, that is APR, that cannot bind SHP1. SHP1 that cannot bind SHP1 means SHP1 is the phosphatase that remove the phosphate. So whenever it cannot bind SHP1, here we can see SHP1 is bound to this receptor and remove the phosphate. Actually STAT activation needs this phosphorylation, so it cannot bind SHP1 means it can bind to the STAT5 and STAT5 become active. So this mutation can be an advantage for the formation of more RBC. Option E, erythropoietin receptor that cannot bind JAK2. JAK2 binding is very much needed. Only JAK2 can phosphorylate the residues of the receptor, then only the STAT can bind. So the signaling is going on. So option A and D are the correct one.